Hi. So in this video, let us put together what we have so far. We got our character motor and our character movement. And let's convert our character into using the state pattern. So a real quick idea of how we're going to do this is we're going to make an interface called iState. It's going to have an enter, an update, and an exit function. These are going to be implemented, or we're going to have the different states of our character implement this iState interface. So we'll have a grounded state, this is where they can walk on the ground, an air state when they're in the air, and any other states. For now, we'll just start off with 2. And finally, when we're going to make a player state machine that just holds a reference to the current state, and it also has the ability to change states, but really we'll be changing states from within the states themselves. If we're grounded and the grounded state realizes we're in the air, we'll change to air. If air realizes we're in the ground, we'll go back to the grounded state. And we're going to update our character movement script. This is where we had everything. We're going to update that to just holding a reference to the state machine rather than having all the code it has. So our character movement script is going to be really small, and all the code is going to be moved out into these states here, really. Okay, so let's start. I'm just going to make a new folder for my states so that, we have it all in one nice place. And we'll start off by making the interface itself. So I'm going to make a mono behavior script, and I'll call it iState. I don't need any of this code that comes with it. Instead, it's going to be a public interface iState, and we'll give it a void on enter, a void on exit, and a void, I'll call it tick. And I call it tick just because update is already a function. So, and also we don't need these parentheses here. So that's our state interface. It has 3 functions to it. And when something implements this state, we are going to need to reference. Yeah, we're going to need to implement these 3 functions. Next, before we start working on the states themselves, let us go ahead and work on the state machine. So I'm going to make a new script, call it, so far we've been calling everything character, so I'm just going to call it character state machine. Just to go along with the name character motor and character movement, we'll call this character state machine. So character state machine is going to have a reference to the current state. So it's going to have an iState, and I'll call it current. So really what we want to do is, I don't think we need the start function right now. We want a public function set state. So this function is going to be how we, oops, it's not even, I didn't need the function there. I need to write void. So we need a function that sets the state. So from our character controller, we can call this set state, and it's going to set the state to whatever state we, wanted to change to. So to do that, we need a parameter. That's the new state. So I'm going to call that next. And really, what do we want to do here? We want to see that if our current state is equal to the next state, so if the current and the next state are the same, we're trying to switch to the same state, then we don't need to do anything. Let's just return this function. I'll make this a little easier to read with parentheses. Next, when we're switching states, we have this onExit function. So when we switch states, right, when we want to set the next state, we need to call the exit of the previous state. So whatever current is before we set it to next, we need to call its exit function. And again, as a safety, because sometimes our state could be null. When we start the game, the state is going to be null. It's not going to be set to anything. So we want to check. We want to check that if our current is not equal to null. So if the current state isn't null, then we can call current.onExit. And finally, we want to set our current state to next. So we're switching, the state's current is going to be next. And when we switch states, we want to call the onEnter function. But exact same thing. To prevent that issue where just in case we go into a null state, we want to check if current is not equal to null. Okay, then call current.onEnter. So there is a shorthand for this. The idea of if it's not equal to null, use the function, otherwise don't. Instead of typing the whole if statement, we just have to type current question mark dot onEnter. And this line is the exact same as all these lines put together. So I can delete this, and that's the same for the onExit. Instead of doing it like that, we can just put a question mark here. So this is just saying if onExit, or if current exists, call onExit, otherwise don't do it. Don't give me an error, just don't do it. And it's just a shorthand, again, makes our code slightly easier to read, slightly easier to work with. Next, we have this, our iState has a tick function. Tick just needs to be called on every update. So we can do that. We just call current, same thing, question mark dot, tick. And that's really it for our implementation of the state machine. All the state machine does is has a reference to the current state. It can switch the states, and it just calls those state functions that we have. Enter, exit, tick. Well, we call on, enter, and exit when we switch states, and we call tick when, on every update. So this is just running the states, and it's going to hold a reference to the current. That's all this does. The bulk of our code is going to be moved into our different states that we're going to have. And we'll start with the grounded state. We're going to have a grounded and an air state. So I'm going to make a new monobehavior script. I'll call this grounded state. Now, grounded state doesn't need to be a monobehavior. We're not even going to have it in the inspector. Grounded state is going to be implementing the iState interface. As soon as we do that, again, we get that error because we're not implementing those functions. So I'm going to start off just by adding those because I think that's the easiest way to do it. We need to have onEnter, onExit, and tick. So let's do public onEnter. I forgot to put void here. Okay, we've implemented these three functions. Error is gone. onEnter and onExit we're not going to make use of right now, but when we do animations, that's where this is going to, come into play. We don't want to run the animation every frame. Instead, when we switch states, we can switch the animations here as well. On tick is where all of the stuff that we had previously is going to be. Now, for this to actually work, we need two references inside our state here. We need a reference to the player state machine itself, or the character state machine, because that has the set state function. So from grounded, if I want to go to the next state, I need a reference to character state machine. So I'll make a reference to that, character state machine SM. Just short for state machine. And we need a reference to the character motor that we had made last video, because that motor is going to hold all the functions, the helper functions, that's going to help our player actually move. And I'll call that motor. Okay, so here's the thing. Because this is an iState, this is not a mono behavior, it's not like I can drag this into the player, game object as a component and get the references like that. This is not going to exist as a mono behavior. It just doesn't exist in my scene like that. I can't even use the term serialized field. It's not going to let me do that because we can't set it anywhere. And because it's not a mono behavior, we can't even use get component. So, I can't get component. Instead, I need when my character state machine creates a I'm sorry, when my player movement script, when this movement script is going to set my state as a grounded state, because my character movement, and I've deleted all the code here just because we're going to add it back, but my character movement has a reference to both the character motor and it has a reference to the character state machine. So it's going to set these two variables from itself when it calls, when it creates this state. And to do that, if we remember in processing, when we make a class, we have access to a special function called a constructor. We make a constructor function just by naming it the exact same as our class, so in this case, grounded state. And when we create a new object of this class, we have to call the constructor. So if I were to set my constructor here and give it the two parameters where it needs a character state machine, and we'll just give it the exact same names, and it needs a character motor. And we can just set them equal to here. So this.sm, where this refers to this class, so this.sm refers to this state machine, equals to sm, and this sm refers to this state machine. So same thing, this.motor equals motor. And so now when we create a new grounded state class, we have to pass it a character state machine, a character motor, because the first time we're going to create it is going to be through our character movement script, which already has that reference. It's going to pass it along, and then whenever we change states, we can just pass this along, to the air state. When the air state creates a new ground state, it can pass this along. And we'll see how that, we'll see that in action in a bit, and it should hopefully make more sense. Next, we're going to just go through the tick event. So I'm just going to run through this. We want to do the exact same things that we had in the character movement. We want to do that here. So character.get inputs. Motor.get inputs, motor.get camera transform. Then we want to make new vector 3s. Get the facing direction. Create our move vector. Then we want to update the coyote timer. We want to update the jump. And lastly, when we jump, right, suddenly our motor could not be grounded. If we're not grounded, we're not in the grounded state anymore. I will just say for now, switch to air state. We haven't made the air state yet, so we can't switch to it, but this is where we'd want to do it. We want to apply gravity, even if we're not on the ground, just so our character kind of sticks to the ground. And finally, we want to do our movement. And so that's our ground state, similar to the air state. In fact, even here, because technically what could happen is our player doesn't jump, but they kind of fall off an edge of something. Rather than waiting till the next frame to get this is grounded, let's just re-add that code right here. So if motor.is grounded, well, you want to switch to air state here as well. Okay, so that's our ground state. Next, let's make the air state. And our air state is going to be fairly similar to our grounded state. There's not going to be too much of a difference. So create new mono behavior air state. So same thing. Let's just get rid of all of this stuff and change mono behavior to I state. We want that void on enter. Well, we want public and just like we did with the air state, we want references to the state machine and the character motor. So character state machine and character motor. And finally, we need to make a constructor. And we don't need this void because it's the constructor. This constructor is never going to return a type, so we don't need to specify that there. And again, let's just add the code that we need from, and the code's going to be a lot similar. It's going to be motor.get inputs, motor.get camera transform. In fact, instead of just retyping everything, I'm just going to copy and paste it from the grounded state, and then we'll work from there. So we have the exact same thing in the grounded state. We can just kind of work from here. We don't need this if not grounded here. And we'll leave this one here but basically it's the same, right? When we're in the air right now, we just get the inputs, we camber the transform. Our animations are going to change here, but it's pretty much similar. We get the facing direction, we can still move in the air. Because we have a coyote timer, even when they're in the air, we can still have them jump. So we're going to check for that jump. We're going to apply gravity. We're going to construct the movement. We're going to move the character. However, our little change is going to be, instead of if checking for the character being grounded or not grounded, we're going to check if the character is grounded. Here we're going to switch. We're going to switch to the ground state. So we already have the ground state made. We can actually switch to it. We have a reference to the character state machine, and we can use that. So sm.next, or sorry, switch, what did we call it? Character state machine, set state. sm.setState. We want to set it to a ground state, so we're going to make a new ground state. And well, we need to pass it the reference to the SM, the state machine, and the motor. Just like that, back in our ground state, we're going to do the exact same thing. We are just going to call sm.switch set state. It's going to be a new air state with the references for SM and motor passed along. Same thing here. And finally, we just need to get the same thing working in our character movement. We just need to call all this stuff to start with. We just need to kind of get it working, in the start function, and everything should kind of catch up with it. So we're going to have a reference to the character motor in our character movement and the player state machine. Sorry, it's the character state machine. And really here on void start, all we want to do is get the motor component, and get the state machine component. And finally, we just want to set the character state machine state to start the game. That's all we need to do, because then the state machine is going to handle the updates and the states themselves handle the switching. So this, the code here is going to be just to get it going. So we're going to start on the grounded state, SM, comma, motor. Go back to our game. And here we just need to add our new component, the character state machine. And hit play and see if it works. There you go. We can still move around. We can still jump, do the sprint that we had before, have the coyote time. And, everything works the exact same. Our entire game has now been switched to using the state machine pattern. You can even see here in my console, I am logging, just on entry, I debug.log with arm and ground or air. Currently ground. When I hit jump, we're in the air. When we touch the ground, we're back in the grounded state. And so, again, this has some trade-offs. This has some upsides. In one sense, we are just learning the pattern, so we have a very simple character controller here. And maybe you could argue the state machine is overkill. If our character controller was growing, this has a couple benefits. One, we can have, it's easier to add new states. It also, in a way, makes it easier to collaborate, because these states being different files means different people can work on it. But there are obvious drawbacks to it. This is the same code repeated here as repeated here. And our code is like separated spots, so it's easier to look at and read, but everything is kind of more all over the place. And, again, it feels a little over-engineered for what it is, but for our purposes, which was the goal of learning the state machine and how to create it, I think this implementation works. I think it makes sense, and you'll see next week, or in the next videos, when we start adding our character and animations, how this all plays through. We might need some more states, depending on the type of animations we want to have. Breaking these air states down, or breaking our grounded state down. Maybe we have a sprint state and a walk state. Maybe our air state has